Welcome class. Today we are going to say about the subatomic particles. If we remember, when I started to explain about the atomic structure or the topic of atomic structure, we started with the meaning of the atom. Okay, so in the atom, there are three small subatomic particles which are called proton, neutron, and the electron. So proton, neutron, and the electron, those are the subatomic particles. So we are going to see the meaning of both of those ones and where they are found in the atom. Okay, starting with the proton. The proton, this is a positively charged particle of an atom. Is a positively charged particle of an atom. It means it has a positive charge, as you can see here, and it is found in the nucleus. This one, this together with the neutron are found in the nucleus. Its mass is about equal to that of hydrogen. Hydrogen has the mass of 1, so proton have the mass of 1. Also, its charge is positive 1. Okay, so its charge, as you can see, it is positive, and it is also denoted by the letter P. Okay, another subatomic particle is a neutron. Neutron, this is the uncharged particle. When I say uncharged, it has no charge. We can say it has 0 charge. It is found within the nucleus of an atom together with the proton. So its mass is equal to that of hydrogen as well, and it is denoted by the letter N, as you can see here. N with the atomic number of 1 and the mass of 0. Okay, and the next one is the electron. Electron, this one is the positive charged particle of an atom. It is found in the shells around the nucleus of an atom. It is found in the shells around the nucleus of an atom. So the structure of an atom, has 3 particles, in which in the nucleus or in the center of the atom there is a proton and the neutron, while around the proton and neutron we have the electron, which revolves around the proton and the neutrons. Okay, so this one, electron, this is the lightest particle of all. Lightest, that's why it can move, and hence contribute negligible mass in the mass number of an atom. Okay, so in the mass now, from this statement we have to know that the mass of an atom is measured from the nucleus. So the mass of an atom is equal to number of proton plus number of neutron. So this one, electron, it does not contribute to the mass of an atom because it is very light. Okay, and its charge is -1. It has the negative charge. So this one we call it the negatively charged particle, and it is denoted by letter E. Okay, and then let us see now. This is the structure. As you can see, this one is the atom. Here in the atom we have the nucleus, in which here it is where we measure the mass of an atom, and then we have the shells, as you can see, these ones, and then we have the the electrons which are attached to the shells, as you can see here. So here in the nucleus we have the neutron, which it has no charge, has 0 charge, and we have the proton, which has the positive charge, this one located by the balls colored yellow, and these are the neutron. But around the neutron and the proton, I mean around the nucleus, this is the nucleus. Around the nucleus we have the electrons. This is the electron, this one is the electron, this and this one, all of these ones. Okay, and this electron, they are attached to the shells or orbit, or sometimes we call them energy level. So here we have the first energy level, here the second energy level, and then these electrons mostly occupy the lowest energy levels. It's like when you are on the stairs. We normally put our leg on the stairs which are down before putting our legs on the stairs which are up. So here the electron will tend to occupy the shells which are nearest to the nucleus comparing to the ones that are far from the nucleus. It means the energy that is required for the electron to be pushed to maybe this second energy level is very high comparing to the energy that is needed to put the electron on the first energy level. That's why the energy, the electron will tend to occupy the slowest energy level, that is the first energy level or the shell, before occupying the second energy level. So we'll see how many electrons are supposed to be in the first energy level or shell, and also how many electrons are supposed to be in the second energy level, and so forth and so forth. Okay. Another is the properties of each particle. Now, no, there's something that I forgot to tell you. The thing that I forgot to tell you is the proton and the neutron together, they are called nucleons. They are called nucleons. So the particles that are found in the nucleus together, they are called nucleons. Okay, so if you meet with a question asking the nucleons, it means combination of neutron and the proton. So from that concept, it means the nucleus is the positive charged particle, because we have the neutral and here we have the positive. So positive and neutral, by the end we get what? We get the positive charge. So the nucleus has the positive charge, but the shells, the orbits, these electrons, the electrons have negative charge. So if we take negative plus positive, what do we get? We get neutral. Again, the atom is always neutral in nature. The atom has no charge. So if maybe a certain element has positive or negative, maybe it is because it has either lost the electron or gained the electron, but in its nature, it has no charge. Okay, now let us see the properties. Here we have the subatomic particles, we have the mass, we have the charge and the location. As we know, I say the proton and neutrons, they are both found in the nucleus, so their location is in the nucleus. Also, the charge is positive 1, while the neutron, the charge is negative, 0, while the electron, the charge is negative 1. Mass, now the mass of the proton is 1, the mass of the neutron is 1, but the mass of electron is 1 over 1940. It means the mass of the electron is very, very small comparing to the mass of proton and the neutron. That's why it's like we do not consider the mass of electron when we are calculating the mass of an atom. So the single atom is electrically neutral. As I said, it has no electrical charge because we have positive and negative. When you add them, we get what? We get neutral, we get 0. This is because in any atom, the number of proton and the neutron, the number of proton and the electron are always equal. The number of proton and the electron are always equal. So the number of protons, the ones that are found in the nucleus, and the number of electrons that are in the shells, in the orbits, they are always equal. That's why the atom is electrically neutral. So in this way, the total positive charge is balanced by total negative charge. So the charges are cancelled. That's why we get what? We get neutral. Okay? From there now, let us